Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Thom Singer and Craig Brown.
Hey there, and welcome back to the Digital Enterprise Society podcast, or welcome to the Digital Enterprise Society podcast if this is your first time tuning in and listening. We appreciate you coming along on the journey of this show that we started 2 years ago to be a resource for those who work in and around PLM. The Digital Enterprise Society is a forum for the exchange of ideas surrounding the tools, processes, and practices used across the product lifecycle. To learn more, go visit digitalenterprisesociety.org. My name is Thom Singer, and I have the honor to co-host this show every single week with Craig Brown. Craig is an industry veteran and former PLM leader at General Motors. Hey, Craig, here we are again.
Hey, Thom. It's good to hear your voice. And here we are again. And I can no longer complain about the cold Midwest. It is now reached summer. So I'll stop complaining about the weather, okay?
Well, we've been doing this show for 2 years. You always find a way to complain about the weather.
Well, okay.
It's awkward to me.
Maybe we'll ask our guest how the weather is where he's at.
It's awkward to me when Michigan is warmer than Texas. That always freaks me out.
Is that going on today?
Yeah. Michigan is warmer than Texas.
Oh, yeah. Okay. So you guys are getting the rain and we're getting the dry heat, but that's okay.
But it's always something. But a highlight of my week, Craig, is when we get together and we do these interviews because we talk to some really smart people who are doing interesting things. And today is going to be one of those. Today we are joined by Ben Kassel. And Ben is a senior consultant, mechanical engineer for a company called LMI. And what he does is he's involved in research and development in computer-aided design and model-based technologies. And he's a little bit of a nonconformist, so he's going to be kind of fun to talk to, I think. So Ben, welcome to the Digital Enterprise Society podcast.
Glad to be here.
So Ben, I know that you started your career, you worked in government for a long time before you went over to the other side and became a consultant. Give us a little synopsis of your career trajectory and your background.
Interesting. I graduated from the University of Maine as a mechanical engineer in the early 80s, and I was hired as a mechanical design engineer. An interesting little story, I was working for a few months, and we had this thing called a computer-aided drafting system. And my boss called me in his office one day and says, Ben, we'd like for you to become involved in using the system. And I was all excited. I said, wow, that's really great. I said, I'm really flattered by this. He goes, no, Ben, that's not the reason. The reason is your drawings are so disgusting. We figured the CAD system is something that just couldn't hurt. And from there, I evolved into using, as an early adopter of, let's say, 3D model-based design. I discovered that there was a third dimension. And even though it was points and wireframe, I then moved on and became more involved in the computer-aided design portion of the problem than using it as a design engineer. And early in my career, I evolved toward the computer-aided design side, primarily research and development in the use of computer-aided design for mechanical design engineering.
But, Ben, welcome to the show. This is interesting because you and I are probably the same age, by the way. and I had to learn how to use a drafting board I'm an aircraft guy, for propellers and airframes, right? And you're right. When the CAD tools started emerging, all of a sudden we could do things in 3 dimensions instead of a sheet of paper, which was kind of nice. But isn't it amazing in the 40 plus years we've each been in this business, what we've done with computers? I mean, we've gone from automating or not automating, maybe easing drafting to now having these things we call models, right? I mean, does it surprise you how fast this all happened?
Actually, it does amaze me. I take a look at some of the tools that are being used today and I think, wow, only I would have had that. Mm-hmm. But it's also a double-edged sword because one of the things that I was told at a very early age was that the computer-aided design system, the CAD system, does not make you a better engineer. It makes you faster, which means if you're a good engineer, it will make you a faster good engineer. If you're not so good an engineer, it will make you a faster, not so good engineer, and it can drive you into areas of danger rap.
Yeah, like management, because you can't design, so we'll just promote you to management, right? But never mind. That's a different subject.
One thing I've noticed also is that I worry sometimes that mechanical design engineering is becoming a dying art, because now that everybody who has a CAD system thinks that they are a designer. And one of the greatest lessons I've learned there was when AutoCAD first came out, AutoCAD and CAD Key. And what happened was you had engineers sending things down to the shop that had strange views, and my favorite, everything had a 3-place dimension on it, and it would drive the shops nuts. Because now what's happening is you have people who don't understand how this is to be manufactured and how it's to be assembled, sending information down. That's one of the downsides I see. The upside is we have tools that, when used in the right hands, can do marvelous things.
Yeah, this point you make about what the shop floor can deal with. A lot of them, I ended my career in the automobile industry. A lot of those guys still demand a 2D drawing for this reason, right? They know that what plane they can look at and what they're manufacturing, and they really don't want a 3D representation that they have to go interpret or learn how to navigate around to get a key measurement. So it's one of the more disappointing things, and it's one of the things we're going to talk about today about model-based something, right?
That's a very good way. I might have to start using MBS.
Yeah, well, or here's what I did. I that E word I turned into everything. I just said, well, everything's model-based, so it's model-based everything. But on a serious note, could you define for our audience what MBE and MBD mean to you? And in fact, what do you think the practice should be? I mean, you're an experienced veteran. What should we be using it with?
Well, let me start with model-based definition, because I truly believe that is the foundation of everything we're talking about today, whether it's model-based E or whether it's what DoD is now beginning to have interest in, which is this digital engineering ecosystem. Without the data, without the technical data, the model-based definition, none of this will work. Imagine, the biggest buzzword right now is digital twin. Without the virtual side, without the model-based definition, there is no twin. So I look at it this way: the model-based technical data is the model-based definition. So the idea is it's the geometry, it's the non-graphical attributes, it's product structure and things like that, which provide you the virtual depiction of a product or even a process. Now then, MBE is a little trickier because I think there are many E's in MBE. The most commonly used and understood E is model-based enterprise. But for today's discussion, I'm going to focus on the model-based environment. And I think the model-based environment provides the computing infrastructure, cybersecurity, and tools that enabled a model-based enterprise to practice model-based engineering. The model-based the model-based environment is powered by the model-based definition, which many people consider, to use a term coined at LMI, TDNA, or the technical DNA. And the technical data is rapidly becoming a core requirement for effective sustainment, and that any system that intends to utilize the digital thread, to utilize conditions-based maintenance, to be supported at some point by mixed reality or the digital twin, additive manufacturing, even material removal processes, will have to have a complete model-based technical data. And to properly manage that technical data requires that robust and stable model-based environment. In effect, actually, you can say that this product model is the technical DNA of your enterprise.
Yeah, and that's what's troubling with at least executives where I came from. A lot of them saw the power of computer-based stuff, right? Whether it's simulation or models or all the other technical data. But they also said, we're in the car business and we take it for a drive. And if we like the way it feels, that's what's going to sell in the marketplace, not how well we manage our technical data. And they're not wrong, but I think they get frustrated with all the different tool salesmen that show up and say, oh, I got a digital twin, or I got a model-based engineering or whatever. I think we've way underestimated you use the word sustainment in commercial businesses. We just talked about the service cycle and whether that's a cost or a revenue generator. tends to be a cost in the car business. And so managing the life cycle after the point of manufacturing has been a weakness in a lot of industries. Is your definition of model-based environment also comprehend the supply chain and all the service attributes, the people that maintain it and improve it for 50 years?
For the majority of time, at least in the past history, the emphasis has always been on design and manufacture within CAD. What we're finding out now is the world of sustainment needs much more information, and they're much more interested in this. And so we have to make sure that our models expand to support the sustainment world, and not just mechanical design and engineering to support the analysis and engineering of a product, as well as manufacturing. So yes, sustainment is the next big growth area for the model-based definition.
And what's interesting from my point of view, model-based enterprises, a lot of companies can say, oh yeah, we're model-based. We got models for the design phase, and we got models for the mass production, and we got models when we want to service it. And they declare themselves digital, right? and then you're like, wait a minute, isn't the thing in the customer's hands supposed to be the thing we mass produced, which was supposed to be the thing we designed? And you find out they're all different, right? Now, part of the reason they're different is because literally they're different silos. They're organizational silos. But another reason they're different is there's different technologies coming, whether that's additive or electromechanical replacing purely mechanical. And so all these different silos exist, partly because of technology, partly because of the way we're trained, right? I mean, do you find that electrical guys and mechanical guys want to share their designs? Do you deal with a wiring harness at all? You're a mechanical guy.
It's interesting. One of the things that we didn't talk about is that for many years, my emphasis was on marine engineering, naval architecture from the perspective of the ship up until the day it goes down the ways, which they don't really do anymore, and it goes in service. And from the marine engineering side, I don't necessarily care about what goes in the pump as much as I do about how that pump is placed into a compartment. At that point, it's more of an AEC.
Yeah, exactly. It's a building. For those not following our acronym, that's the same stuff you do when you're manufacturing or designing a building, right? Where do you put air conditioning? Where do you put plumbing? All that stuff.
Yeah, the only major difference is these buildings that we work on in the naval shipbuilding world are designed to float and be shot at.
And move.
and yes, move. And what I find interesting is that it's interesting that you really bring up the term silos or islands of automation, because I believe that the highest return on investment has been manifested through the implementation of these islands of automation, because it's easier to observe the improvements and quantify the cost.
Oh, yeah, exactly. Because we can measure it, then we can get credit for doing it, right?
That's the interesting thing, too, the rice bowl. The risk is lower because a smaller internal organization controls the entire process. The goal is to develop a product model environment that can accommodate the continuous improvement of individual processes while improving the efficiency of the overall organization. And that's when they come together, because 90% of my time, I'm going to be down in that silo working on that little component that's going to go into a pump. But every once in a while, I got to come back up and make sure that harness hooks to my mechanical component. So yes, in some cases, islands of automation are important. And that's where we're going to find the greatest improvement in product design. But we also have to be aware that at the end of the day, we're building an overall product. And our boss's boss's boss doesn't care that we got the latest whiz-bang finite element software. Right. They care that they can move a product.
Yeah, and well said. So you talk about technical data and it being based on the model, or having the model organize the technical data. In my experience, those silos organize their technical data very differently, right? And they tended to be driven by whatever the manufacturing constraint was, which is where the capital investment was. So for sheet metal, it was bending it, right? And so there's these big presses. But for wiring, it was how to make the harness so that you could install it in the car in, a few minutes, right? which is difficult when you look at the amount of wire in a car now. So can you imagine a single place for your technical data? I mean, is that possible, or is there something else that has to happen?
Actually, I've been a proponent lately of a concept which is called domain-specific data definition.
Okay.
And that my experience has been that we develop data definitions and translators from the perspective of an application, such as manufacturing or engineering analysis. You're a mechanical engineer. Think of how many Nastran neutral data decks you generated off of your CAD system so that you could run a static structural analysis, or how many how many lines of G code you generated from that model so you could send it down, so you could send your shape down to the shop, regardless of whether or not you had feeds and speeds in there or not.
Right.
Didn't matter, but you needed to get the geometry in a friendly way. The idea, though, is what we do is we define the product from the perspective of an application. We are neglecting defining the product from the perspective of the product itself. And a lot of these emerging technologies, whether it's new design information visualization techniques such as mixed reality, or whether it's this new ubiquitous digital twin, or additive manufacturing or itself, the idea is if you don't define the product, the perspective of the product, its behaviors and functional characteristics, these new technologies will not work. It's not just enough to build technical data from the perspective of its destination.
Yeah, you're on another one of my pet peeves from where I came from, where we talked about the performance, right? The functional performance of a product. And of course, the PDM people, they said, well, yeah, just attach it to the design. And I said, but we know the performance requirements 8 months or maybe even 2 years before we actually have a product bomb figured out, right? We don't know what parts we're reusing and things like that. So where do I put acceleration of the vehicle? On the top level model, on somewhere else in the design, or do I create an object like some of the tool vendors have called a requirement, and I just let it hang out in space and I associate it later? So where do things like behavior, how does this thing work when it's in motion, and overall performance like fuel economy, where do you hang those in a model-based technical data? I'm not sure it's on the geometry is my point. What do you think?
Actually, I don't believe it's on the geometry.
Okay, then where is it? How do I find it?
I could get into, I could sit there and describe what I think is the model-based environment. The product model definition is a combination of the shape that you just mentioned, but also non-graphical attributes, product structure, and the relationships between the data, whether it's the topological relationships that enable associativity and design features, or if it's relationships between non-graphical information. If you think about it, it is that combination of all those data forms that transforms a stereotypical CAD model into a product model data, into a product model. Because the non-graphical attributes define that function and behavior. Taking this, define that behavior. Now, the question comes down to is, where do they go? And I think from our perspective as product developers, and when I say product developers, I mean parts and small assemblies that may get assembled into larger assemblies, that may get assembled into that nasty S word, system. And what I concern myself with is the confluence between systems engineering and product engineering.
Okay.
And there is such a push right now for systems engineering. I sometimes worry that the needs of the product engineer are lost, that we're being totally consumed by systems engineering. So to answer that question, if it turns out that those attributes you talk about are requirements that are going to drive how we build our product, that would be provided by the systems engineer and probably provided into either some external system such as a doors or maybe the PLM system. I wasn't going to mention any. I was going to try to stay away today from mentioning any product names, and that was my third one, I think, that I said.
Well, it's really difficult, just so you know.
I know.
Keep going. So it's taken me 2 years to get in that habit.
Whether it's in a PLM system, I hate that term, by the way, also a PDM, an ERP, and things like that, these requirements come from different places. And it's what I like to consider the product data manager, which is the tool which will integrate the CAD system with all these other higher level enterprise systems, whether it's ERP, MRP, PLM, XYZ, who cares? And it's that idea that I can integrate externally defined non-graphical attributes and integrate them with my geometry and topology that allow me to have the look and feel of a product model in my computer-aided design environment?
Right. And
Means I didn't really answer the question.
Well, no. I think you did, because I think, in fact, it's bringing together these. There was a gentleman at NIST who described it as cylinders of excellence, right? Rather than calling it a silo and making it sound like it was bad habit. In fact, the reason the silo develops is because that's where the expertise is, right? The cylinder of experts get together and they say, well, yeah, if we're going to do, we'll talk about additive for a second. If we're going to manufacture this through a 3D printer with metals, powder, what is it we need to do? And how does that fit into the overall system that has some performance requirements? But, especially additive, it just changes all the rules. So all the money you needed for a die and at least to bend metal or some kind of foundry to build a hunk of metal and drill it to death to make it into an engine block. These are all different when you get to additive. Additive all of a sudden is just build it in shapes you can't even imagine because you don't have to worry about manufacturing constraints anymore. So the way we organize the data that help us make decisions is a big deal. And it helps if we get back to the fundamentals, and part of the fundamentals is physics. Another part of it is what's driving your business, right? If you're going to embrace additive, chances are the drivers are going to change dramatically. And, the only problem with additive is it's new. It won't be new in another decade. It'll be commonplace. And so then lots of people will be doing it, probably service people, because one of the costs, at least in a car business, is keeping machines around to build parts for a 10-year-old car, right? Nobody wants to do that. Whereas printing a new part, heck, you could do that at your auto parts store, right? Maybe. We need technical data exchange to work really well, by the way.
That's a real interesting thing because, I get accused of total heresy these days because to me, additive manufacturing is nothing more than another tool in the producibility workbench. And in fact, I don't know that additive manufacturing the way it is used now is new, but additive manufacturing isn't new. It's probably one of the oldest manufacturing processes. Take a look at welding. Yeah. And in fact, in one of the early times, they call it buttering now when you're building up large weld joints from multiple layers of weld. Right. But that was also used to build parts thousands of years ago. You heat metal and you build it on top of each other. Yeah. It may have been the first manufacturing process. I don't know about that.
Well, hardened steel for Middle Ages swords was in fact exactly that, right? You keep folding the material over and over, pounding it into an ever strengthening sword, right?
It's interesting you bring that up. I some of my spare time, I'm an adjunct professor at Capital Technology University in Laurel, Maryland, and I teach a materials class. And the very first lecture I give is about the Damascus steel and the way it's made. But we diverge.
Okay. Well, so material properties, let's go there for a second, right? That matters a lot in your mechanical design, what materials you choose or how you go through hardening it or strengthening it, whatever your processes are. That's got to be part of the technical data as well, right? It is inclusive of the manufacturing process, and for that matter, all the processes, engineering and service included. Would I be right in thinking that? This is going to get complicated if we put it all in there.
It's interesting that you bring that up also, because we talk about where are we going in the world of a computer-aided design. And I see that with these islands of automation and things, and how do we move forward into a more collaborative, faster environment? And so I see that a computer-aided design, one of the hot terms these days is integrated computational materials engineering. And how do I integrate materials characteristics as I'm doing my structural design?
Right.
And then the next thing that happens is, and you talked about earlier about, mechanical and electrical and all these other disciplines. And there's some tools that are coming out right now. For instance, there's the multidisciplinary analysis optimization in which we think we're operating in a truly integrated environment in parallel, but not really. But computers are so fast and the software works so well that I can take my CAD model and I have a structural analysis and a thermal analysis, and I might have some electrical things, and all these things are running around each other, and I'm able to sit there and optimize across domains.
Right.
And another interesting thing, one last thing is, and then there's this design technology that's been in vogue for the last several years called set-based design. Mm-hmm. So when I combine my islands of automation, I enable multidisciplinary analysis optimization, and I put it into a set-based design environment, I'm approaching that nirvana of the collaborative real-time design environment and multidisciplinary.
So does that eliminate engineers, or do we just need a certain kind of engineer now? And does engineering need to change? I mean, I have a specialty, you have a specialty, but it sounds like we need to just be really good engineers at everything. That gets overwhelming, doesn't it?
I'm actually old enough that I was involved in the transition from the slide rule to the calculator.
Yeah, me too. There's so few of us left.
A lot of people surmise that as calculators came out, that the need to learn how to add, subtract, multiply, and divide would go away. A lot of people have surmised that as these functional solvers came out, that the need to understand calculus may go away because now I have these symbolic analysis tools. And I don't think that anywhere, at least in the near future, and I'll go out on a limb and say that I cannot see within the next 500 years that the human will be eliminated, regardless of the amount of new helper technologies come out. I refer specifically to AI and ML and things like that. I still think that the human in the loop, that the creative mind, and that the ability to be able to rapidly make decisions with respect to past performance and where the future you want to go will still be there. So no, I don't think the engineer will go away, but I do believe that the way the engineer does their job will change significantly.
Yeah, and I think the A is, we always talk about computer-aided design or computer-aided engineering for simulation. A good friend of mine coined computer-accelerated. What's really going to happen is just we can accelerate engineering, and for that matter, manufacturing and others, with all these computer-based technologies. So we won't need fewer engineers. What we'll need is just realizing the pace of change will probably get faster and faster, which is probably a good thing, right?
Yeah, I believe the goal is to make our engineering profession more efficient.
Yeah. So we've been asking our guests, and we're in the good news cycle now in the pandemic, at least in the United States. But do you think the pandemic has changed the way we're going to work? Are we at the cusp of a new way of working?
You know what? I don't think so. I think what it's going to do is bring it out of the closet. I believe
what we've been doing. Okay.
I believe telework has been around, and the need to be able to work in incredibly diverse environments, geographically speaking, for many years. One of the things is I was a government employee, and one of the things that happened was telework was not very well received in many of the organizations. Not within the organization I'm in. My boss's boss's boss did not like telework at all. My boss's attitude was, look, if you need to work from home today, or if you want to go to a quiet place, you want to do this, well, let's not telegraph what we're doing, but as long as you can do your job, let's do it. I have been teleworking and working bizarre hours for the last 25 years. So what I see is it's now being, all of a sudden people are realizing, well, if you're not in the office, the world didn't crumble. Well, the world is crumbling, but the world didn't crumble from the perspective of the workforce. And
yeah, right. It only crumbled from the perspective of the Dilbert boss who only knows how to count noses and not look at real productivity, right? Which is what really matters. And so the fact that we've remained productive is an interesting piece of insight for management.
Yeah, I think what they're seeing is that, you know what? It does work, and it can work if it's managed correctly. It's like any other tool. It needs to be managed correctly. If you have the worker that's going to abuse the system, they're going to abuse it whether they're on site or at home. They'll find ways to do it. If you have the self-actualized employee who is the go-getter and doesn't really need a whole lot of motivation, they're going to work just as well. In fact, they might work better because when they need that private time, they've got it. When they need to come into the office to collaborate face-to-face, they know they have to do it, and they will. Now, one thing I've seen also is many enterprises are now looking at, I can reduce my capital footprint and I might not need those 5 floors in that building anymore. Next year, I'm only going to rent 4 because I'm going to put some of these people in permanent telework.
Yeah, exactly.
Well, the only thing that I see, and it's a double-edged sword also, is the social aspects of the workplace.
Yep.
I consider myself a stereotypical curmudgeon. And if you would have told me 2 years ago that I would have missed some semblance of human interaction in the workplace, I would have laughed at you. But even I still like to be able to do face-to-face.
Yeah. It's a human need. It's nice to have less of it, for the record, but it's still a human need. So, Ben, this has been a joy chatting with you. And at this point, I'll pass it back to Thom.
And I really appreciate hearing that even curmudgeons are missing being around people. That as a guy who teaches people how to connect more and cherish those in-person relationships, I'm going to add that into my next keynote, that even the curmudgeon says he wants to get back to where there's some people. So thanks for sharing.
In a limited setting.
In a limited sense, right? Just an hour a day.
Let's not take it too far, Thom. I get it. I got it. All right. Well, Ben, thank you so much for joining us. And thank you for everybody who tuned in and listened. Please make sure that you mark your calendar. Every single week on Wednesday, a new episode of the Digital Enterprise Society podcast comes out. So join us every single week because we're going to bring you more thoughts, ideas, and information in and around product lifecycle management. And remember, the Digital Enterprise Society, it is the place for the exchange of ideas around digital manufacturing tools. Go check us out at digitalenterprisesociety.org.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you've heard here today at digitalenterprisesociety.org. Join us again next week for more connection without boundaries and creation without limits.